Here we come to higher level examination physics 1990 question 4. So we have a coin placed on a turntable at distance r from the center. So the turntable is rotating now. It is said that the maximum friction between the coin and the turntable is equals to 0.5 mg. Okay, so now we have to consider two things. Firstly is when the turntable is rotating, if the coin is not going to skid, the centripetal force required would be given by m r omega square. So here we have the friction to provide the centripetal force, and the friction is given by 0.5 mg. So as the turntable rotates faster and faster, the centripetal force required is larger and larger. Okay, until a certain point, the centripetal force required is so large that it is larger than the frictional force that can be provided. In this case, the coin will skid because the friction is no longer enough to provide the centripetal force required for the rotation. So I don't want this to happen. I don't want the required force to be larger than the frictional force. So in order for the coin not to skid, the centripetal force required must be less than the friction force provided. So we have enough force provided to rotate the coin together with the turntable. So we can set up an inequality like this. mr omega square is less than or equal to 0.5 mg. So now the question asks us, in this case, the coin will begin to slide when the angular velocity is, okay, so we are calculating the angular velocity, the maximum angular velocity. Okay, so the maximum angular velocity would happen when mr omega square is equal to 0.5 mg. And we are going to simplify it a little bit. So m is cancelled out. And then we put omega max square, or just omega max, to be the subject. So we'll have an expression like this. Therefore, 0.5 can be written as 1/2. So we have an expression